Hello everyone. In this video we will be talking about while loops. Like for loops, while loops allow us to repeatedly execute a code block. However, the key difference between the two are the conditions we can specify for them. In a for loop, the condition is that our iterator falls within the range of what we are iterating through. Lists, tuples, dictionaries, even a simple numeric range. And as long as no errors occur, at the end of an iteration, that iterator will update and get closer to the end of whatever we are iterating through. In a while loop, the conditions can be much more broad. In fact, think of any condition you could put in an if statement. That condition can more than likely be used in a while loop as well, from checking to see if a variable has been set to a specific value to checking if a particular event has occurred, like a button being clicked. Because of this, while loops are incredibly useful for programs that need to be able to run for an indeterminate amount of time. Games and applications use while loops to keep them running. Tools that use networking capabilities use while loops to continuously send and receive data over network sockets. There are a lot of things that while loops can be used for. So let's start with a basic while loop to walk through the construction of it. We start here with our keyword while, and then we add our condition here. In this case, we have x is less than 10. Then, as you might have guessed, like with for loops and like with conditionals, we gotta add a colon to the end of this line, and then we create a new line and add an indentation to start our code block. For our code block here, we're going to print x, and then we're going to increment x by 1. Now, for this loop to work properly, we have to do something before the loop can actually start, and that's initialize x. In for loops, x will be initialized for us, so we don't have to start it beforehand. But with while loops, we have to actually create an x beforehand and set it a value. Otherwise, if we tried to run this code without x equal to 0 before it, it will just throw an error and say that x doesn't exist yet. So we have to create x and assign it a value before this while loop can actually start. In this case, we're going to create an x and assign it the value of 0. It's going to iterate through this, increasing x by 1 each time and printing out the numbers from 0 to 9. Much like how we would say a for loop would iterate through a range of 10. Now let's go ahead and run this code. See? It prints out from 0 to 9. Now there are two ways to establish a while loop. I've already demonstrated the first way, where I established a condition in the while loop definition. But we can also define a while loop that simply states while true, like you see here. Like I demonstrated with if statements, while loops evaluate the condition to see if it is true. And since the Boolean true value equals true, the condition will evaluate to true. So why would we use a while loop in this way? Well, sometimes there is a number of conditions that need to be checked to see if the loop can continue running. And while we can use logical and or keywords in a while loop condition, it can look a little crazy, not to mention unreadable, and it can get really long and really annoying. I have an example of what that could look like after this one. But as you can see here, we've got two loops, and they both do the same thing. They're going to print x, then increase its value by 1, and then it's going to check to see if x meets a condition. In this first case here, x is going to be checked by the condition of the while loop itself. The while loop is going to check to make sure that x is less than 10. So once it reaches the value of 10, it's going to stop and get out of the loop. Whereas this one, the while loop is just checking true. So it's going to constantly run no matter what. However, we added an if statement in here. If we say that x is equal to 20, then we break out of the loop. So if I run this, so in the first loop, we've printed out 0 through 9, then it breaks out of the loop, and then the second loop, picking up where it left off, x is at equal to 9 at this point, so it will print out 10, and then continue down until it hits 19. Once x reaches 20, the while loop will break out, and 20 will never get printed. So here's a couple of examples of when we have multiple conditions that a while loop could have to keep running. So in the first one, we have a pretty complex while loop. As long as x is not equal to quit, and the type of x is an integer, and the x falls within a range of numbers, it's going to loop through it and do something. Now, as you can see, that's pretty complex. And there could actually be way more complex loops. These are just basic examples dealing with a simple data type. There could be other situations where we're checking a feed that's reading from a file or reading from a network socket, and it could be a little bit more complex. It could be checking a application and checking its status to see if it should still be running or if it should close the program. So in those cases, it'd be a lot better to just say while true and then establish a couple of if statements that check the value of x and do something based on what that value could be. Plus, this one is a little bit better because in this situation, if the value doesn't meet any of these two conditions here, then it'll just say invalid input and then loop back to the top, giving the person another chance to put in some valid input. And in this while loop here, if the user inputs something invalid even once, it'll just end up breaking out of the loop. And, sometimes that's just not the intention a person has. They want it to keep looping until they finally enter something valid. So in some cases, it just comes down to personal preference of a developer and how they want to code their while loops. But there are tons of cases in which just saying while true and then establishing your conditions inside the while loop to control whether it skips over code or breaks out of the loop in the loop itself. However you do it, just make sure you actually put a way for the while loop to actually stop. Which brings us to a very important thing to talk about before we go any further with while loops. A flaw that you don't want to have in your code: infinite looping. A key difference between for loops and while loops is that the looping in for loops is controlled by Python, whereas with while loops, it's up to your own code to control what keeps the loop running and how it should be stopped. And if you're not careful, a while loop with no way to leave will trap your program in an infinite loop until you force the whole program to stop. Let's look at an example of an infinite while loop. So here we have x equal to 0, followed by a while loop that will check to see if x is less than 1. And as long as x is less than 1, it will print x. What you've noticed here is that we don't actually ever modify x. X never increases, it never decreases. We probably wouldn't want it to decrease in this case, but we would at least want it to increase. So if we run this, we will be trapped inside this while loop and it will be constantly printing 0. So if we run this, it's constantly printing 0 with no end in sight. It's just going to keep running. Now, fortunately, I'm running this in Jupyter, so it's as simple as me clicking that stop button right there. But in an actual Python program where you're running it in the command line, you're going to either have to close the command line, you're going to have to go through your task manager to stop the program manually or something like that. You're going to have to force it to quit the hard way. And that's not something you want your program doing. I've even broke Jupyter apparently because it can't handle the fact that so many zeros got printed out. And that's essentially what infinite looping is: a loop with no way out. No condition capable of evaluating to false, no break function to call. The only way to break out of it is to forcibly terminate your program. Now, real quick, I mentioned that we can use logical and or and while conditions when talking about infinite looping. That's not all we can use. We can also use the not keyword in while loops as well. I've got a pretty basic example here. We wouldn't really write a while loop in this fashion. We would just say while true. I just wanted to keep this example simple. But what we could do is maybe call a function that would constantly return false until a specific condition was met. Then it would return true. So we could say, while not that function call, let's do this. And then once it finally hit true, then it would exit out of the loop. It's pretty much the same as before. We've got x equals 0. And as long as that variable doesn't equal a specific number, it's going to print that variable and then increment that variable by 1. So if we run this, it prints out 0 to 4. Now let's look at a couple of real use cases for while loops. These may be very basic use cases, but they are incredibly useful. There are, of course, more advanced use cases because the sky is really the limit when it comes to what you can do with while loops, but we're going to keep things simple for this video. Now let's start with a simple but fun example: a text menu. So here we've got a variable choice. It's set to 0 by default. And then we've got a while loop here that's checking to see if choice is not equal to Q. And so long as it's not equal to Q, it will keep running that while loop. And each time the while loop runs, it's going to print out a menu giving us 3 options to pick, followed by prompting us for user input. And don't worry about the user input line. Next video, I'm going to cover user input. So just know that this will prompt you for user input. I'll go into more detail about it next time. It will assign the input to choice. And then down here, we'll check choice to see what it's equal to. If it's equal to 1, it will print out a message to answer the first prompt. If it detects a 2, it will print out the message for the second prompt. And if it detects 3, it will print out the message for the third prompt. If it's not equal to any of these numbers, it will just loop back to the top. But if it detects it was hit the Q, it will exit out of the while loop and the program will end. So I'm going to open up my terminal screen. Make this a little bit bigger so you can see it. So it prints out our menu, gives us our 3 options. I'm going to type 1 and press enter. And it prints out the message: shuttles, frigates, and small cruisers may dock here. If I press 2 and hit enter, it prints all ships must submit to customs inspection. If I press 3, it says we're clear to land at dock 1. And if I type anything else, it will just ignore the input because it doesn't match any of the conditions and it'll repeat the message. But if I hit Q, It closes out of the program. We can also use while loops to iterate through data structures. We would just have to use a counter and manually update it ourselves instead of relying on Python to do it for us. You're probably wondering why would we do that when for loops are a lot simpler? And technically they are. They help us go through data structures to read the data, use them in other functions, and sometimes we can even modify the elements if we need to. However, with while loops, we can safely modify the data structure itself. This is not something we could safely do in a for loop. For starters, the only way to do this is to utilize the range function so that we can access elements of the list directly using indexes. The problem is that the for loop only executes the range function once, at the very beginning of the for loop. It won't execute it every single time it iterates through a list or a range. This means that if you want to modify the size of the list within the for loop, it's going to cause some problems. Removing items to decrease its size will eventually cause an out of bounds error because the code in the for loop tries to access an element in the list that no longer exists. It won't call a range again to update the count. If you had like a list of 9 elements, and say you deleted the element at index of 5, then when it reaches the index of 8, there's not going to be an element at index of 8 because there are now only 8 elements, and therefore the last element in the list will be at index of 7. That'll create an out of bounds error. Adding items won't be as harmful as removing items because it won't exactly cause an error unless you have something that would cause an error. However, it won't iterate through the entire list then. Say you have a list of 9 items again, and you added a few more items, and now you have like 13 items. It will still iterate through the first 9 items, but the last 3 items in the list won't ever be touched. And if they needed to be iterated through for some reason, the for loop wouldn't have done it because it already created the range for the original 9 elements. And that could be particularly troublesome if you inserted those elements inside the list somewhere specifically and not just appended them at the end of the list. So I have a few examples of what would happen if we tried this in a for loop. So in this example, we have a for loop that's deleting elements from a list. So anytime an element is found to be equal to 0, it will delete that element from the list. The problem is that it will make this list shorter than what the range is specified for, so at some point, it's going to cause an out of bounds error. So if I run this, you see it crashed here. And so we never get to see it print out this list because it crashed in the middle of this for loop. Now in this example, we're adding items to the list. This won't cause an error, but the items added to the list won't ever be touched. So in this for loop, any number that's found to be less than 0 will be multiplied by -1 and then appended to the end of the list. So if we run this, it sorts through the first initial numbers, which is -1, 3, 4, -5, -9, 5, 6, 7. But when it prints out the list after the for loop, you'll see that there are additional numbers added at the end. It didn't go through them in the loop because the range was specified for the original list size. Both of these issues can be resolved with while loops. So for this first example, any item that's less than 0, we're going to remove it from the list. So if I run this, we see the initial list with the positive and negative numbers. We print out all the numbers as we iterate through the list, but when we print out the list at the end, we only have positive numbers. Now this is a more advanced while loop, so let me walk you through it as well. So we have our x equal to 0, and we're checking to make sure that x is less than the length of the list. Now, this will be checked every single time at the top of the while loop. Unlike a for loop, which only measures the length of a list once, the while loop will measure the length of the list every single time. So we can compare this value to the length every single time and get an accurate comparison. So the first thing we're doing, we're printing the element that we accessed. Then we're checking to see if that element is less than 0. And if it is, we delete the element from the list. If it's not, then we just increment x by 1 so we can move on to the next element in the list. Now you're probably wondering, why don't we increment x by 1 after deleting an element from the list? Well, if we did that, we would cause the while loop to skip over numbers. You see, when we delete elements from the list, everything will shift. So if we deleted -1, 3 would no longer be at index of 1, it would be at index of 0. If this 3 was negative, and we incremented by 1 after deleting the element, we would skip over that -3 and it wouldn't get removed. So we have to account for the fact that elements in a list are going to shift whenever we modify it, whether we add items or delete items. In this case, we don't want to increment by 1 after deleting an item from the list because we'll end up skipping over numbers since everything shifts. Now in this example, we have the exact same list and we have the exact same condition. But this time, instead of deleting elements that are negative, we are simply multiplying those elements by -1 and adding the result to the end of the list, making this list much larger. So not only will we be printing out the original elements of the list, but we will be printing out the new elements that were added during the while loop. So if I run this, we've got our original list, and here we have the 7 from the original list, but then we have 1, 5, and 9, that were generated when we found the -1, the -5, and the -9. And then at the end, we print out the whole list. And that's like one of the big things that while loops can be really useful for is modifying data structures while iterating through them and not breaking the code. And those are just some basic use cases for while loops. There are much more advanced use cases, a lot of other cool things you can do with while loops. I can't really get into them in this video because it would require me to use things that we haven't gone over yet. But as we go into more advanced stuff in this tutorial series, I'm going to be using all of this stuff because these are just the basics of programming. So when we get into the advanced stuff, I'll be using these basics and I'll be showing you more advanced stuff and that essentially serve as more advanced use cases for all of these things. I'm just using basic stuff because I want you guys to really be able to understand the core concept of what this stuff can do. So I know this may seem a little basic and boring now, but trust me, as we get farther along in this series, we're going to get into a lot of cool things that we can do with all this basic stuff. I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. If you want to see more, head on over to the Wayfarer Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.